In this video, we will give an introduction to Vision and AI Lab. Video Analytics Lab was established in 2010 and we are now Vision and AI Lab in 2023. We aim to perform world-class research in the broad fields of computer vision and machine learning to push the performance limits on different applications and ensure the reliability in practical settings. Our recent focus areas include 3D human pose estimation, domain adaptation, efficient adversarial defenses, learning from long-tail data, smoothness-aware training, image editing in latent space of GANs, mitigating biases in ML models, and neural radiance fields. Most of our research findings were published in top vision and machine learning venues such as CVPR, ICCV, ECCV, NeurIPS, ICML, AAAI, ICLR, and ACMMM. Publishing in these top venues gives better visibility and higher impact as shown by the Google Scholar metrics here. It is actually an exciting time to be in AI research. The number of papers submitted, accepted has been growing rapidly in recent years. This slide shows the rapid increase in number of papers submitted for CVPR in recent years. The number of accepted papers for NeurIPS in recent years is shown in this slide. This also shows an exponential growth. Many such top-tier conferences saw such an exponential growth in recent years. If you look at what is our country's contribution to these top venues, it is quite disappointing. We are merely contributing around 1% of accepted papers in these top venues. For example, India has contributed only 19 papers out of 1900 accepted papers in 2020 NeurIPS. Vision and AI lab members consistently publish in these venues. The stats show that we have published about 57 A-star papers in the past 5 years, which is more than 10 A-star papers every year. This is indeed a remarkable achievement for any CS lab in India. IISc is ranked as the top institute according to the popular CS ranking portal. Our Vision and AI lab at IISc tops the list, indicating its leading research contribution in India. This slide shows some of Vision and AI lab students' achievements in recent years. Our past PhD students are working in top academic institutes as well as industries. Our current research students and Vision and AI lab explore various aspects of computer vision and machine learning. In the following slides, we will look at some of the current research works done at Vision and AI lab. Long-tail learning is an important area of research in machine learning that focuses on improving the performance of models on low-frequency categories. In many real-world applications, the majority of the data falls within a few high-frequency categories, while the remaining categories, the long tail, have significantly lower samples. This imbalanced distribution can negatively impact the performance of models on long-tail categories, which can be critical for some applications. Long-tail learning techniques aim to address this imbalance by improving the representation and classification of long-tail categories, leading to more robust and accurate models. My student Harsh, a PMR scholar, is working in this area. Research work on long-tail learning were published at major machine learning and AI venues. Datasets for training ML models are often obtained by crawling the web and thus reflect several biases in the society. Training models on such biases can amplify them. How can we mitigate this? Mitigating dataset bias is a critical area of research in machine learning. Biased datasets can lead to unfair or inaccurate models that can perpetuate discrimination or inequity. Mitigating dataset biases involves developing techniques to identify and correct biases in datasets. By mitigating dataset biases, machine learning models can be made more reliable, robust, and equitable, leading to more fair outcomes in various applications. Shown here are some of our recent research efforts towards mitigating biases and spurious correlations while training ML models. Adversarial robustness of deep models is another important research direction pursued at Mission and AI Lab. Adversarial attacks are a type of attack in which an attacker intentionally introduces small perturbations into the input data of deep learning model, causing it to misclassify the input. Adversarial robustness techniques aim to improve the robustness of deep models against such attacks by introducing additional constraints or regularization during training. However, these techniques can often result in a significant increase in computational cost and training time. Therefore, developing efficient adversarial robustness technique is essential to enable the deployment of deep models in real-world applications, where efficiency and scalability are crucial. Efficient adversarial robustness techniques can improve the security and safety of critical systems, leading to more reliable and trustworthy AI applications. The real-world adversarial attacks can have serious consequences, such as compromising the security and safety of critical systems, including autonomous vehicles, access control, and medical diagnosis systems. Most of our adversarial robustness works were presented in prestigious venues such as NeurIPS, CVPR, ECCV, and PAMI. Image editing by latent space manipulation is an interesting and emerging research direction where we can change various attributes of a given image. In this work, we estimate the direction in the latent space that control attributes such as smile and eyeglasses. The following video gives a clear picture of the work presented at ACMMM 2022. For more details, please visit our webpage and feel free to email me if you require additional information. Thanks for your attention.